This is Wasmela Stanley presenting to you the sampling procedure for agricultural data collection in Kayunga district. This assignment was given to us, me and Zach Mukasa, by the DPO. The objective of this particular assignment is to guide on the procedure of getting a representative sample size for different enterprises in the production department. As you've seen on this slide, there is a population, as you see in the photos, and a sample. The population simply is a collection of all items of interest in the study, and the sample is a subset of a population. Now, as you see, when we decide if we are to collect data from a population, it will take time and it will be too expensive. So, in most cases, when we are dealing with a study, we sample a population, but the sample must be a representative sample from the population. The data collected from the sample must represent the characteristics of a population. In other words, when you're picking a sample, you don't just pick a sample, you pick a representative sample. You don't go to a population of 2,000 people and you pick a sample of 20. The data from 20 people will not be representative of the 2,000 people in the population. There is this term which is called the sampling error. It is the difference between the characteristics of a population and a sample. Now, because we are dealing with a sample is picked from a population. The data we will get from the sample will not necessarily be the same as the data for the population. For example, if we decide to pick the mean height of people from the population of the photo I've shown you before, and the mean height of the people in the sample, there will be a difference. So the difference between the mean height of the population and the mean height of the sample is what we call the sampling error. The bigger the sampling error signifies the inaccuracy of the data you've collected. The smaller the sampling error signifies the accuracy of the data you've collected. Solving's formula of determining sample size. Now, as I've noted before, you don't just pick a sample size, you pick a representative or an appropriate sample size which will reflect the characteristics of the equation. So this equation is a simple equation of solvings where n denotes the sample size, capital N denotes population, and E is the sampling error. So this equation takes into account of the sampling error so that you come up with a representative sample size. This is an example. I decided to take on an example where the total population, for this case we are talking of total number of households, where the total number of households in a particular sub-county is 1,000. And we are considering a sampling error of 5%, which is 0.05. We will get a sample size of 286. Now, because we are dealing with households, us as a production sector, we don't know the number of households in the respective sub-counties. So we qualify secondary data. Secondary data is picked from published data. Now for this case, it will be the National Population and Housing Census of 2014, which clearly states the number of households in every sub-county within Kayunga district. And it is this number of households that we will use to come up with the sample size for the households we need in each sub-county. After determining the sample size, now the task ahead of us will be deciding the sampling technique. In most sampling procedures, the random sampling or probability sampling is used. Now, it is of different types. We have what we call simple random sampling, systematic random sampling, stratified random sampling, cluster random sampling, and multi-stage sampling. But during this study, we are going to focus on simple random sampling, which is number one, and stratified random sampling. Now, stratified random sampling deals with stratas. A strata is a subset. Like in our sub-counties, in a sub-county we have parishes, we have villages. So a village is a strata. A sub-county is a strata. So anybody going to do sampling of the 286 people or the 286 households we have got will have to deal with those stratas to sample from those stratas. The slide shows you a sample map of a sub-county. I'm trying to illustrate more about the sampling procedure. If we got that for total number of households of 1,000 in a sub-county, we need a sample size of 286. It means if we were to consider a parish as a strata, in this particular sub-county, the parishes are 6. So we get the 286 sample size of households and we divide by 6 parishes. It will give you 47, literally meaning you will pick 47 households from each parish for data collection. Or another one can decide to consider villages as stratas. For example, if this sub-county has 40 villages, we will divide the 286 sample size we got from the example in the slide before, and we divide by 40. If it gives us 5, it means that from each village we are going to pick 5 households from which to collect data. And that data collected, the characteristics of that data will be representative of the total number of households or of the total population. Thank you for listening. Waiting for your feedback.